Hi everyone, fluid mechanics. In this example, we have like an uprising airflow, air jet, which collide in an upside down cone with a degree of 60 degrees. And if the cone applies a force of 0.25 kilonewton to the airflow and dissect it into two branches of flow in a symmetrical shape, the cross section and diameter of the entrance air is provided, the velocity of air is provided, the density of air is provided in both units. We want to calculate the mass of the cone in this problem. So to start such problem, we can start with the momentum equation. So if and also for the simplicity of the problem, we have like the density of air in the SI unit because the dimension are in SI units. So that's 1.25 kg over meter cube. And let's consider like pi is equal to uh, number 3. Square root of 3 is equal to 1.7 and g is equal to 10 meter per square seconds, just in terms of simplicity of the problem. So considering this simplification, we can start with the momentum equation. Summation of forces is equal to rho q differences in velocity delta v. So to start the problem, a force applied to the cone is in negative direction, negative f. A W, which is a mg, is again in a negative direction, minus mg is equal in the second part is rho q. If you keep a closer look, the total angle of this cone is 60 degree. When it when the air jet just collide with the cone, it just dissect to two symmetrical branches of flow. Each of them is q over 2, a half of the q, and then definitely the velocity is v cosine 30. So the two of them, rho q over 2 cosine times v cosine 30 plus rho q in the other side, rho q over 2 times v cosine 30. And if you add them up, it just turns to be outgoing flow is rho q times v cosine 30 minus incoming, which is rho q v. We are subtracting the outgoing minus incoming, and then just simply first replace the density of air, which is 1.25, which is provided in problem statement. Then F is provided to be 0.25 mg. We just consider that g is 10 meter per square seconds, and then we need to calculate q. Q is nothing but area times velocity. The diameter is provided, velocity is provided. We can simply calculate the airflow, which is 0.3 meter cube per second. Replace it in this equation. Then we have we can also take the velocity out of the parentheses, that's 40, and then the leftover is cosine 30 minus 1. Based off our simplification, square root of 3 is 1.7. Replace it in the problem, divided by 2, subtract it from 1, and solve it for the only unknown of our problem, which is the mass of the cone. It just gives us a mass of the cone is zero point 0.2 kg. So based off momentum equation for this problem, we calculate the mass of cone is zero point 0.2 kilograms. Thank you. We'll solve more problem in the momentum equation in fluid mechanics. Thank you.